Hey guys, thanks.
Hey, hey. Sorry to cut you off with the record sound there. But hey, everybody, it's the 28th of January, 2025. This is Aiken PBL live coding from Gimbalabs and Friends. Lot going on lately, and we have kind of a smaller crew here today. So Harsha and I were just talking about maybe spending a little bit of time playing around with the Asteria code base because it's written in Aiken, which is pretty exciting. So that gives us a chance to look at some Aiken in action. We'll talk more about the Asteria project on Wednesdays. We're going to really make this the focus of the time where we used to be dedicated to Plutus project-based learning, but it all blends together here, right? We're talking about validators and app development. So let's jump right in. Harsh, you've been getting familiar with this directory. Which validators have you been spending most time with?
So I just got through asteria.ak, and what I have been trying to do is, as a first step, at least be able to read the validators.
Yeah. You want to demo it for us? So I see a validator here on line 14. What does that sound like when you read this validator?
So when I read this validator, what I understand is that uh, you are creating a validator that takes in these parameters, which is the admin token, the shipment Lovelace, the maximum Asteria mining, and then it spends like a UTXO. And to spend the UTXO, it takes in the datum parameter, redeemer parameter, UTXO, and the transaction parameter. And then uh, it actually starts like, uh, so it actually, before that, it actually checks whether these things let transaction, uh, it's actually checking if um, it's basically matching. Um, yeah, it's. I think it is pattern matching, or at least that's what I understood. It's pattern matching here. And then when redeemer is add ship, expect exterior output list filter. Hmm.
Can I play with this just a little bit here?
Mhm.
So yeah, that's a really good start, right? And so one thing to look at, you mentioned these parameters. These, and this is a critical concept, any kind of Aiken anybody's looking at. We started looking at it last week with a very basic example. These are completely arbitrary. The developer of a smart contract can make these parameters inside the validator here whatever they want. And I'm
Mhm.
distinguishing that from these parameters, which are the required parameters of the spending validator. So we have a validator called Asteria. Its purpose is spending. Now, does it have any other purposes? Well, if I just use this nifty little arrow, right, in VS Code, I can collapse the spending part of things here. Whoops, that only collapses the parentheses. Let me collapse this whole piece from this bracket to the next one. And look at what we notice here. You see how everything is in the spending validator. Is there any other purpose for this script? No. Else underscore. That means for any other purpose, mint or governance or credentials, right? All of those will fail. This is only a spending validator. And you were taking us through this logic, but look, the meat of the logic, right? Most of this file is on the 80 lines that are right here. Okay, cool. And does that surprise anybody, or is that kind of feeling like it makes sense so far?
Yeah, that's all good.
Good deal. All right. So we've got that part. That's cool. Now, when we really start digging into the spending validator code, we get to this add new ship. And I've found myself describing this as an endpoint. Okay. I don't know if everybody would agree um, with this terminology, but to me, it makes a lot of sense to think about the name of a redeemer as an endpoint to this spending validator. And if you're familiar with other programming languages, you might, in TypeScript, you might have an object called Asteria with another object inside of it called spend and an object inside of that. So we could say like asteria.spend.add new ship would be one of the endpoints to this application. My question is, how many other endpoints does asteria.spend have? I see one right here. Let's collapse it. Oh, here's another one. Mine. Okay. Here's another one. Consume Asteria. Ah, there's three of them. Okay. And if I go up here, I can see that in asteria.types, the redeemer was defined. Let's just open that file for a second. That's going to be probably in the lib types. I'm looking for Asteria Redeemer, and there it is. And there's these three. Remember, we talked about enumerated values a couple weeks ago. These are the three possible values for Redeemer. It might as well just be 0, 1, and 2. But if we just use the indexes 0, 1, and 2, it wouldn't have any semantic meaning to us. So it's helpful to be able to put a name on each of these. But these words don't add anything to our logic other than giving us the ability to name the endpoint we're working on. And that's exactly what we see right here. Okay. Redeemer could be 0, 1, or 2. 0 represents adding a new ship. And that has this logic right here. How much did that align, Harsha, with your mental model so far?
I think it landed perfectly.
Okay, perfect. Right. So adding a new ship, I could speculate about what they mean by that, but where in this code, what stands out to you about just this block right here? Where does it appear that the ship is being added? How is it represented?
So it's validating the add new ship. So it's just making sure that you have the same data, that you're holding the admin token, that you're incrementing the counter, and that you have the same policy ID. And it's validating all those parameters. And if so, then you add a new ship, I guess.
Okay, so who's the you that can add a new ship?
The person that's submitting the transaction.
Right. And what has to be true about what that person holds in their wallet? You see that right here.
Yeah, they have to have the token with the policy ID and the token name of the admin token. They have to hold the admin token.
Bingo. And so
Yeah.
this is another critical pattern, right? What we can do, and this is obviously the entire early history of Cardano, people understood a lot about policy IDs because unique policy IDs were used to identify NFT collections. And that's wonderful, but it's only a small part of the story. This is showing us right here that the real use case for a token with a given policy ID is that it can be validated against in any logic right here so that we can say, yeah, you can only unlock this token. You can only hit this endpoint to add a new ship if you can prove that you hold some admin token in your wallet with a given policy and name. That's pretty cool. Okay, so this is access control with some admin token. The policy doesn't matter, right? It can be derived from anywhere, but we see that whatever it ends up being, that's a parameter right here. So in other words, let's take a step back. Some of you have learned in other courses or maybe elsewhere that you can create a policy ID via different methods. And one of the easiest methods is just to create a new key and to create a simple native script that says that this token can be minted if signed by, right? If the minting transaction is signed by this key. And that's how a lot of early policies were written. That's actually still completely valid, right? We could just grab Cardano CLI right now and just create a random new policy ID. But then we could protect the private keys for that. We could mint that token only to the people we wanted to be admins. And then we could throw the asset class right here. What's an asset class? Oh, it just needs a policy ID and a name. Admin token is an asset class. An admin token has a name and a policy, just like any token, right? So we could define those arbitrarily. We could hand those out to the people we wanted to be admins, and boom, there's the admins of this project. They're the ones who can initialize new ships. Could we be more complicated about our minting policy for an admin token? Of course we could. We could write a validator. We could write a multi-sig. But in any case, at the end of the day, what we're looking for is a policy ID that only falls into the hands of the people we want it to, because it gives them this ability right here. So that's one. Next to holding that admin token, you got to cover the fee. What is the fee? Ah, it looks like it's specified here. Ship mint Lovelace fee. Aha, that's another parameter, right? This could be 0. If I wanted to just make it free for people to add ships to an Asteria game, I could just set this integer equal to 0, and this would be taken care of basically as an always succeeds. But any non-zero number right here, um, that would then have to be covered in the logic down here. That's pretty cool. So how much are we going to charge for people to add to the game? We want to count how many ships there are, so we take care of that. Where is that going to be stored? In some Asteria output datum. Asteria datum has a ship counter. It also has a shipyard policy. Okay. So once again, we follow the same pattern. Asteria datum. We're destructuring it, sure, right here. But just to cover our bases, where is that defined? Oh, right next to Asteria Redeemer. And here it is. Okay, those are the only two fields in this type, a counter and a policy. So we also need a policy ID for ships. I'm going to want to understand that a little better. And I can't argue with this. It would be nice to know at a global level how many ships have been created. I don't think this is strictly necessary, but it's a nice thing to demonstrate. And Asteria is first and foremost a learning tool. So this is just showing you that you can have some kind of master datum, okay, that has some global state of the entire instance of the game. And why not? It adds a little bit of logic right here. These two lines add a little bit to the transaction fee. But in return for adding a little bit of execution cost, we now have the ability to just look at that datum and in a simple query, look at the number of ships that have been created. We could also just query the policy ID on chain and count how many tokens there are, but that would be a heavier query. And if we could just keep the number right here, this also gives us the ability to compare. I would always hope that this number is equal to the number of tokens that have been minted. And this one, anybody have any ideas why this is necessary? John, did you have any lines like this in your code for like equival? Hey, Hinson. Hey, Jonty, by the way.
Yes, what's up? Hello, good.
What's happening?
Yeah,
Tell us why we
we
need lines 53 and 54 here.
oh yeah, so let me see. No, I have not been following quite closely,
Caught you.
but thanks again. Looking forward to learning more.
Yeah, man. What do we have right here? So, right, this just says must preserve shipyard policy. And what we're seeing here is that the output datum, the shipyard policy in the output datum must be equal to the shipyard policy. But where was original shipyard policy defined? Ah, that's from the incoming datum, right? We had as our input. So we spend some datum, we spend a UTXO that had some datum on it, right? Spending. That datum is going to be basically erased, right? We lose it when we get to this point of spending the UTXO. And so we're going to need to replace it with new datum. And that's a good thing because we want the new datum to have an incremented counter. However, we don't want some malicious actor to come along and while they're just increasing the number of the ship counter, we don't want to allow them to change the policy ID. So we just add a guard right here. We say, hey, the new datum has to have the same policy as the old datum. That can't be changed. And anytime anybody tries to change it, this validator will fail. Any questions about that bit? So global state, I would describe this. Here's our first endpoint, adding a new ship. I think of this kind of as like a global state validator, right? It just gives us the high level picture of the game. So what else can this Asteria validator do? It can mine. And this would add new ship was about 30 lines. This one's about 40 lines, maybe a little bit more complicated. Mining. I have a guess as to what that means. Because there's a little bit more logic here. One of the patterns that you're probably already noticing, I don't think we've fully covered this in the course yet, is at the end of this endpoint, what are we going to return? Always we want a validator to just return true or false. Often that Boolean statement, yes, you can validate or no, you can't, is going to depend on a set of conditions, not just a single thing. And that's why we see and right here. You don't have to use this logic or this kind of pattern right here, but it's the best way to do it. Okay. When does add new ship return true? It returns true when must add fee is satisfied and the admin token is present and the counter is incremented correctly and we're preserving the shipyard policy. So usually when I read a new validator like this, take mine as an example, I might skip right down to the end. Okay, in order for this validator to validate, three things are going to have to be satisfied. And I can read this. If the code is good, it should give me some clues about what I'm looking for. Okay, it looks like there must be an input ship token. Whatever they mean by respecting max mining, we're going to have to look at that and preserving datum. Oh, preserving datum, that feels familiar. So that one looks pretty easy. Here it is right here. Does the datum equal the output datum? So essentially, where in add new ship, we were able to change the datum a little bit right here, but we preserved the policy. In the mining endpoint, the datum should never change at all. So mining was not going to change the number of ships, and it's not going to allow us to change the policy. So I feel good about that one. It looks like the more interesting ones are these two. and we can look up and we can find them. Input ship token. Here's a let statement. Okay. Must input ship token. We're going to go option.isSum. IsSum sounds interesting. Let's talk about that in just a second. But where is option coming from in the first place? Option. Maybe it's up above the first endpoint. Option. Where is that defined?
Is it the same option that is listed by Asteria datum?
I think its option is a library in Aiken. So if you scroll up, there should be
Oh,
Aiken
yeah.
slash option. Then they're just putting the function off the option.
Perfect. Thank you. It's an import. I broke my own rule and didn't review the imports first. Brilliant. Okay, so let's go find that library just to understand this syntax a little bit. I'm going to switch over to a web browser. And I have to find my Zoom again. So Aiken, and I find option. There it is. Boom. And it was this. So option.isSum asserts whether an option is sum, irrespective of the value it contains. Okay, good. So we've looked at option before. Remember that the value of option can be, yes, there is some of that data, or none. No, there's not. And so what does this say? It just asserts whether an option is sum. We don't care about the actual value. We just want to know that it's not nothing, right? And here we go. There's a counterpart right here is none. Oh, okay. Just return true if option returns none. That's nice. I actually didn't know about that. I'm learning as we go as well. So now if we go back to the code, option. Okay, so let must input ship token. We want to find that there is a value in a list of inputs. So we're going to map over the inputs. And for each input, we're going to list the tokens. And then we're going to check if there are any tokens there that have the name we're looking for. And there's a utils function, utils, built into this library itself, Asteria utils here as prefix. So this is just a simple function that takes some arbitrary prefix and some full length asset name, and it checks to see that the prefix is the first n characters of the asset name, right? So take the length of the prefix, chop off the first whatever, however many letters that is, chop off that many letters of the name. Does that match the prefix? If so, okay, yes. And what are they using for the prefix here? They're using ship. So I'm curious. This is actually kind of interesting. Oh, so it can't just be any token with the name ship on the front of it. It also has to have the shipyard policy. Beautiful. So we're going to go through all of the inputs. We're going to map over. Okay, so we're going to map over the inputs. For each input, we're going to map over all of the tokens in the input. if one of those tokens has the shipyard policy and the prefix ship, then this whole option is some, right? Is going to roll up to a yes. And that's all we're asking. We're not asking for which ship token is there. All we're checking is that there is any ship token present. And if there is some, right, that'll be true. So list.find, let's confirm this by looking at the docs again. I would assume that list.find is going to return option. Is that correct? List.find returns, of course it does. It returns option A, right? If it finds the thing we're looking for, it returns some of that thing. And if it can't find it, it returns none of it. So if the function we're looking at, if list.find returns any successful tokens, option is some will simply return true, and this condition is satisfied. Any questions here? I'm just modeling how I would talk through this out loud and understand it for myself the first time. But what holes am I leaving? Does anybody have any other questions here or other ways to describe it? So that's, we can check, okay, is there a ship token in any of the inputs to this transaction? Is the datum unchanged? So the only thing we haven't looked at is this one, must respect max minting. So this uses the compare with function, which takes from int output rewards. Looks like a comparison operator and rational.mul. Ooh, this is a juicy one. So I want to find out where's compare with coming from. That's coming from Aiken math rational. Okay. I don't want to read about that. From int, same. Okay, we're going to have to go look at the Aiken math library in just a second. We're going to learn more about this operator when we look at the compare with documentation. And same thing, rational.mul. So we're already pulling in compare with and from int. I'm not sure why they didn't destructure mul right here. It's probably just easier to read to not destructure that one. But you could, just like we can have from int and compare with, we could have just imported mul in the destructuring right here. We'll leave it the way it is for now. And then it's using that from int again and a sub right here. Let's break this down piece by piece. I'm going to go to the documentation, but I'm going to keep my eye on this as we read through the documentation, and then we'll come back to this. Let's go to the docs. So the first thing I want to look for is that Aiken math. And then within math, it looks like everything we need is coming from rational. Operations between rational numbers. Internally, rational numbers aren't automatically reduced. This is only done on demand. Rational new. Okay, so it doesn't, you can't compare 2/3 and 4/6. Great. Only happen after reduction. Looks like there's a reduce function down below. Cool. The ones we're really interested in, let me start with compare with, and then we'll skip around. Compare, combining, ordering. Here's compare with. And with refers to the fact that we can just supply whatever, look, function. Oh, so that's some really just clever syntax that allows greater than or equal to as a symbol to be interpreted as a function that returns Boolean. That's just some really nice shorthand. We'll go back to that on line 92 in just a second. Comparison of two rational values and a chosen heuristic. So yeah, compare. So we're saying output rewards is greater than or equal to rational.mul of input rewards over rational.sub from int1 percentage. All right, so rational. I'm assuming rational.mul is multiplication. Yeah. Multiply left times right. Fine. And I'm assuming that rational sub, yep, gives us the difference there. So it's just multiplication and subtraction. And then rational itself gives us a numerator and a denominator. And so let's go back and try to read this guy now. So this must respect max mining is going to return the truth value of this number is greater than or equal to. There's that clever syntax right here. We don't have to write a function. This is a little bit like Haskell, the fact that you can turn a symbol into a function. And then this output rewards needs to be greater than or equal to the product of input rewards times 1 over the percentage. Where's the percentage? Percentage comes from max Asteria mining out of 100. All right, so max Asteria mining serves as a percentage. Where's that defined? Ah, an int. That's our third parameter. Okay, so this third parameter here would be a number between 0 and 100, I presume. You could make it greater than 100, but then it wouldn't ever limit anybody. Okay, so some percentage of what I need to understand a little better, but some percentage of mining is allowed. And I would have to play with the game a little bit to understand the role this number plays, but here's a first chance to learn about it. So we're just going to take whatever that parameter is and turn it into a percentage, right? This over 100. Okay, that's our percentage. Fine. It's derived directly from the parameter. Then we say, okay, well, some input rewards, input reward. Oh, they're right here. Okay. Input rewards. Asteria input, output value. Right. So we get the amount of rewards from the Asteria input. Fine. We get the output from the output. Fine. It's a value, notice. Oh, but it's Lovelace of the value, right? So we're only talking about Lovelace. Fine. And we need to make sure that the output Lovelace is greater than or equal to the allowed percentage of the input. Cool. Right. Because what is this endpoint called? Mining. So whatever rewards exist in the input, this percentage defined here as an integer. So 70 would be 70%. This basically says you can't withdraw more than 70% of the available rewards. There's this much input. Multiply whatever is here by, say, 70. The output must be more than that. Must be more. I think I was just describing less than or equal to. Anybody want to take a shot at talking through this logically? I'm tripping over myself a little bit. Output, the output has to be greater than the allowed percentage of the input.
So I just have a small input, but this is just from the docs I read. So Asteria game says you can mine half of anything that's available.
So that would mean 50 right here.
Yeah.
So let's say there are 1,000 ADA available with a limit of 50. So if I came along and said, hey, oh, sorry, this is what I was messing up. Output rewards. Is that what's being sent? No, that's what's staying at the Asteria output. Ah, that makes more sense. Look, so this is a little bit misleading. I read output rewards as what the player gets, but it's not. It's actually what's being returned. So there's 1,000 rewards available. That's the input rewards from the Asteria contract. We say that you're not allowed to take more than 50% of them. Okay. So the most you would be able to take is 500. And that would mean that the amount going back to, not out to the player, the amount going back into Asteria would have to be at least the other half. Yeah, that's nice logic. Okay. If I made it 70%, then we would say, yeah, there's 1,000 available. You can, we must preserve. So this is really the amount that must be preserved in the treasury. If it was a 70, then we would say, okay, out of the 1,000, 70% of that would be 700. A minimum of 700 must be returned. And so this would only validate if the player took at most 300 of those 1,000 ADA. Okay. I would call this like maybe remaining rewards or something to make it more understandable to myself, but I think I get the idea of what they were going for. What do you think? Okay, so mining, I think that's the win condition, right? When somebody gets to the center of the board, they get to claim their rewards, and this limits how much they can claim. We can add a new ship if we're an admin and if the fees are covered and the datum is appropriately handled. We can mine if we have a ship token and we are only taking our fair share and we're not changing the datum. This doesn't yet talk about the conditions for being able to mine in the first place, but we can look at that. And maybe this isn't talking about rewards. Maybe this is talking about fuel, but we'll get to that. There's these other three contracts. Okay, mining. And then what else can we do? Consume Asteria. Check there is a wallet with the admin token. What does this mean? This might just be the endpoint for closing out the game. Okay, I think what they mean here is that anybody who holds the admin token can spend the global state UTXO that runs the game in the first place, effectively ending the game. Yeah, that would be just game over. But Harsha, is this actually helping?
No, it absolutely is. Yeah. The only part I didn't understand is the ending part. Like, once you consume the Asteria, the game automatically ends in the previous step, right?
Yeah,
Uh,
notice like this doesn't care about outputs, right?
mhm.
This is the only of the three inputs that has nothing to say of outputs. So really, even more than ending the game, this endpoint just says basically if you have the admin token, you can do whatever you want,
Oh, got it. Okay. Okay.
right? And this is a common practice for especially when you're in development mode. And there's a valid argument that somebody could make that would say, hey, yeah, of course, like leave this endpoint for admins while you're in development. But if you really want to build a non-custodial and non-ruggable system, you would want to eliminate backdoors like this one that allow the holder of the admin token to just run over the game whenever they want to.
Makes sense.
So just to cover our bases for today, this is awesome. This is where we are headed, and we can give the same treatment to these other three files now or in the weeks to come. And I just want to remind everybody, we're going to be meeting same time on Wednesdays for the Asteria development team at Gimbalabs to just do whatever they need to do, get help, ask questions. That's going to be really, really fun. Looking forward to getting that up and running tomorrow. Um, but for now, let's go and take a quick look at the lessons for today because actually we just leveled up like three times faster than I was planning on. But maybe today's lesson will be really easy. So I'm going to change my screen share one more time and jump over to here. Oops. Am I sharing? I can't tell. There we go. What up, Henson? What was cracking you up?
Hey, hey,
Hey, hey.
I just heard that you say level three times up.
We went fast, but let's see what this looks like. So if I jump over to Aiken PBL, our plan today was to start on module 202. Well, what's this module about? It's about writing smart contracts where we have validation on the inputs themselves. And if you've been following along with our little tour of the Asteria code, that's exactly what we've been doing. Let's just jump in a little bit, right? To write any to write any novel application, there's just absolutely no doubt that you're going to have to validate against inputs and outputs, right? We've shown you so far how to do some general validation. You can validate on signatures, so only certain wallet holders can use your app. You can validate on time, which is absolutely helpful. You can validate on fees or whether or not inputs and outputs exist. But at the end of the day, a lot of that is just boilerplate. Is it likely that time is going to play a role in your application? Absolutely, it is. So you will use that. Is it likely that you'll want to give access to only certain pub key hashes? Maybe, but in my experience, not likely. As you just saw, a better tool we have is an admin token. And this allows you to not have to rewrite the whole application just because somebody loses their private keys or whatever, right? You can transfer a role with a token, but you don't really have as much flexibility if you're relying on pub key hashes. So a lot of what we've looked at so far in module 201 has been really good background knowledge. But in order to build any sort of novel business logic, right? If you really want to build an innovative application, there's absolutely no doubt that you will be validating on inputs and outputs. And this is where you have the chance to be as creative as the TX Pipe team. right? We were just looking at some really interesting validators there with arbitrary parameters and specialized datum. And we were looking at very specific ways to investigate both the inputs and the outputs to those three Redeemer endpoints that we were just looking at. And so let's see if some of this other stuff looks familiar. The lesson examples are in the same repo as usual. And I'll jump to VS Code in just a second, but just a little review, right? We have this concept of inputs and outputs. And let me just jump into the Aiken standard library for just a minute, right? In the documentation right here, what is an output? An output, right, which your UTXO essentially from some transaction. An output has the address that it was outputted to, right? The receiver address of some transaction receives an output. That output has some value in it. Value can be Lovelace plus any number of native assets. Datum, which is optional, right? And that's how datum is defined. And then also optionally some reference script. We talked a little bit about this last week. We're not going to focus on reference scripts for today, but as you get to deploying your application, this is going to be really important. And we certainly will be looking at this when we look more at Asteria. But this is the key thing, right? An output has to have an address. It has to have value. That value has to at least have Lovelace in it. And the simplest UTXO you could make is just one where I send to Harsha's address 5 Ada, right? It's got his address. It's got 5 million Lovelace in it. Boom, that's a really simple output. Sometimes it has native assets. Sometimes it has datum. Great. Now, an output reference is the identifier we use for a UTXO. What do I need to know in order to tell you about some UTXO or to write the code in my application? I need to know the ID of the transaction, and I need to know the output index. Every transaction produces a list of one or more outputs. If I write a complicated transaction with 4 different outputs, all 4 of those outputs will have the same transaction ID. They all came from the same place. And then each of them will have a little, what do you even call that symbol anymore? A hashtag, right? It has the hashtag symbol and then an integer. So you've got your TX hash, hashtag 0 or 1 or 2 or 3. And that's the output index right here. And that's all you need to then use some prior output in a new transaction. When I have the inputs, this is what I identify to say, yeah, I'm going to spend these transactions, hashtag 3. So what's an input? Well, an input is just the combination of these two things, right? It's the identifier and the content. An input has an identifier, the output reference, and it has content, right? The output. This input was the output to some previous transaction, hence UTXO. So far, so good. How's everybody's mental model of the fact that every input is just an output with an identifier on it? Is that okay when I say it like that? Awesome. 3 thumbs at the same time.
Yeah, good.
Very good. All right. So now that we've got that, let's go back to the Aiken code. And instead of reading it through these lessons, well, I'll just scroll through here, right? Everything I just said. You've got outputs, you've got inputs. Every transaction has inputs and outputs. We know that. And we've got some different examples to look at. The first one, which I'm going to open up in VS Code in just a minute, doesn't care about datum and redeemer. All it cares about is that there is some transaction that goes back to the validator address. So I'm going to go through these notes in real time right now by switching back over to VS Code. I'm going to switch out of the Asteria project and back into Aiken PBL. Then let's go to module 202 and close everything else. Okay, so here we are. Input addresses. This is another fairly short validator. Ooh, I can read the whole thing on my screen. Unlike those complicated Aiken examples, right, with many endpoints. This is just a single endpoint. It's a validator. Notice no parameters in this simple example. This validator only has a spending endpoint. It can't be used for any other purpose. We use underscores on datum and redeemer because we're not validating against them. They can be safely ignored. That underscore, remember, is just your way of telling Aiken, hey, ignore this. We're not going to use it. So we have input and TX. The input, let's see, where do we use input? Right here. We'll get to that in just a second. And the TX is used right here. And you've heard this word, and you'll see it in the written form of the lesson. We are destructuring the transaction right here, right? Remember that a transaction has lots of different fields, but we're just saying we only care about this one. And then we use dot dot for all the other ones. So we know we have a full transaction. For the purpose of this validator, let's just look at the inputs. Forget about the outputs, the fee, et cetera, et cetera. So those are our inputs. We got a list of those. We got some input in question, which is the one we're validating against. Semantically, this can be a little hard to imagine. So let me just draw a little picture right here in a comment, right? We know that any transaction has inputs, and it can have a list of those inputs, right? Input one, input two, input three, et cetera, right? That's this right here is what inputs is referring to. When we say this input right here, what we're basically saying is, hey, look, which one are we trying to spend, right? In any transaction, you can have many inputs from many different places. If you're taking an input from my wallet, I have to sign for it, right? But if I have an input from a validator, that's where this script is actually going to be doing its job. And so this input refers to the one input in this list where we have validation logic. Maybe this is it, the input validating. All right. Erez, what do you say?
Yeah, hey James. The for the transaction part with destructuring, you have inputs. What are the other things that would be representative of the dot dot in the transaction?
That's all in the transaction documentation, and we've looked at it in prior lessons. Let me give you a
Oh,
quick
okay.
review. I think we have it here in our list.
Okay, yeah, I've missed some of them, so I can go back and look
Here
when
it
I have
is.
time.
In mock TX, in lesson
Oh, okay.
103.1, you can see here's everything a transaction has: inputs, reference inputs, outputs, fees, etc.
Okay, so it's like a property with keys and values with
Yep. Yeah,
okay,
and
cool.
that's at the core of the Aiken documentation. You'll see full documentation of all of this.
Okay, cool. Thanks.
So my transaction has a lot of inputs potentially. A validator can only check against one of them at a time, right? And so this input is referring to the one out of this list that we're validating, but we have a list of inputs because there might be many, right? Now, of course, is it possible for a transaction to only have one input? Yeah, of course there is. And that's a very common case. But right here, we're imagining the also common case where there's many inputs to a transaction. So what we then have here is, okay, we have the input we're validating, we have all the inputs in the transaction, and then what do we say right here? Aha, here's a couple of those key words that we keep running into. You can bet that when you're writing your code, expect and sum are going to be really important. Expect means, hey, assume this is going to happen. Assume this will be satisfied. And if it is satisfied, keep going. But if your expectations are not met, stop. So what do we expect? We expect some, right? Remember, some is the opposite of none. Expect that we will have some own input. And what is own input? Oh, we're going to find an input. Where is that defined? Find input. It's built into Aiken's Cardano transaction library. Okay. So go through all of those inputs from the whole transaction and find this one, find the one that we are talking about. Now, obviously, if this fails, if there's none here, there's no reason to be running this code in the first place, right? Because we're trying to validate against some input being an input. So, of course, this validator should just stop if we find none own input. But assuming that everything is the transaction is valid, yeah, of course there's going to be this own input. And this name right here, remember, is arbitrary. This was confusing to me at first when I was learning Aiken. I thought that own input was like when you pass, this looked to me like some function definition, but that's not what it is, right? This is giving a name to the value that we find. So expect that you find some of this, and when you find it, call it this. Ah, okay. And once you have it, keep going. So now we can keep going, assuming that we only get to line 53 if line 52 succeeds. And if line 52 succeeds, we now have an own input that we can refer to. And this is where our logic happens. Okay, so when the inputs at inputs own input dot input address is a list of length 1, we return true. For any other list, right? A list with length 0, a list with length 2 or more, or any other none response or bad response, any of that's going to return false. This validator should only return true if we find exactly one input that satisfies this. But I want to understand more about inputs at. Inputs at. Where was that defined? Ah, here we're not pulling in the Aiken libraries. We're pulling in the helper libraries from Vodka. And cocktail means that we can use it in production, right? It's not just for testing. It's not just a mocktail. This is actually a really helpful function. So now I want to go to the vodka docs and read a little bit about inputs at for a second, because I'm not 100% confident reading this out loud. I just want to understand what this thing is doing and what it's supposed to return. So let's jump to the vodka docs. Vodka. And let's see, cocktail. Okay. And that was I'm in cocktail inputs at. I'm going to assume that's in inputs. Public function inputs at takes a list of inputs and some address, and then it returns a list of inputs. Okay, so that makes sense to me. I was hoping to see this part, because remember that our check was checking that the list has length 1 or it doesn't. So it makes sense that this is going to be a list. That's wonderful. A list of what? A list of any inputs filtered by address, right? So any inputs that have address as their address field. The reason this helper function is nice, right? Like we could obviously, I could write this line of code by myself and I wouldn't have to import inputs at, but this is nice and semantically readable. So I don't have to over and over again say that, wait a minute, remember that an input is actually an output and an output has an address. Oh my gosh, I'm seeing these words over and over again. Why am I talking about outputs here? Oh, right, I'm talking about that because every input has an output, right? Like this is just a really nice helper function to eliminate some of that cognitive load and get us into that, right? And so if I go back to the code, let's try to read this again. We say inputs at, take our whole list of inputs from the whole transaction, there they are, and just see if any of those inputs came from the address. Which address? The own output, right? The address that matches the validator. Now, why do we want to check if it's length one? Well, in order to get to this point, it must have been true that it was a non-zero amount. So really, what this is doing for us is it's just checking that you can only take one input at a time, right? You can't unlock multiple inputs in the same transaction. What do you think?
Yep. Actually, I could add a comment, or do you want
No, keep
let
going. I love
others
it. I
to?
love it. I'm
Yeah.
tired of my voice. I just went for like 70
So
minutes straight.
these three lines themselves seems a little bit innocent, but actually it is a pretty common pattern of Aiken script. Because for a lot of simple script, if you didn't add this check, usually you're implicitly allowing people to unlock multiple script inputs at the same time. So the problem with that is a pretty infamous kind of vulnerability in Cardano core double satisfaction. Like imagine there's a validator that you lock in one access and you want to do a simple swap. Then people could kind of unlock your multiple inputs by providing you the same consideration. Just like put it in a simple example. For example, you're locking 50 ADA and you want it in exchange for a stable coin, like 1-to-1, maybe 50 USDM. And then you lock in another UTXO like 100 ADA for 100 USDM. Then what one malicious participant could just give you 100 ADA, 100 USDM, and by the same time fulfilling your 50 ADA order and the 100 ADA orders. Meanwhile, it's kind of violating your expected behavior, which is 50 plus 100. So yeah, so for this is just a simple illustration, but for a lot of different Cardano dApps, a lot of the time you don't want people to conduct this double satisfaction unlocking. So there's a pretty common coding pattern to prevent this. Yep, the name of the problem as James just typed it out was double satisfaction.
So you're showing us some really nice patterns here, but right, at the end of the day, the real magic is right here to prevent that double
Yep.
set. Yeah. It's almost like this should just be a helper function. Does vodka have this all rolled up into one?
Not really, because trying not to be too opinionated.
Yeah. But you could write a helper function for it. Like any of us could.
Yep,
If I was
definitely.
writing a production code base, I probably just want to protect against double satisfaction in every spending validator I write. So maybe I can wrap this up in its own helper function and use that as a util throughout my project.
Yep. Another reason why I try not to wrap this thing into the packages. For some cases, some dApps might want to have two exactly inputs or three exactly inputs, number of inputs
Yeah,
or outputs.
that's right.
It's really case by case. So yeah, this is why I just try to keep it as unopinionated as possible. Just with a simple filter, so you could do whatever pattern matching you like.
Very nice. Yeah, most of the validators I've worked on, it's you must have one input from this validator and another input from that validator, right? And so that's another thing you'll often see is that it's not even just about consuming from only this validator, but you can imagine that it gets much more interesting when you have the ability to say, hey, you can only spend from here if you're also spending from there. And the way you would identify that idea of, hey, where's this other place you have to spend from? Oh, well, that would be a validator parameter, right? I can write one validator that takes another one as a parameter, and now they are dependent upon each other.
Yep. And then following this line of thinking, we very quickly unveil some design pattern. Like what if you want each validators to use each validator's address as parameter, then you run into cyclical
Yes, exactly.
compilation. Yeah, that's not not for today, probably.
But that's I'll never forget the moment that I realized that problem. You know, I think that's a really exciting one for people to kind of come to on their own. Like, yeah, this is wait,
Yeah.
if this one depends on this, but the other one depends back on that, how do I know which one? Oh no, I can't, you can't compile it at the end of the day, but it's kind of good to know why. Okay. Um, so now these tests, right? What do we have? We have a Oh, this is a clever use. So this is you showed us last time like the ability to quickly include or not include inputs. So this little Boolean right here is the one that triggers the inclusion or not of this second UTXO. And so when this guy has one UTXO, it's going to pass, but if it has both, it's going to fail. And yeah, here you're saying, right, is only one input false. This is really, this is nice testing. Are these patterns right here that you've used in Delta DeFi?
Yep. So as everywhere else, including a lot of open source contrast I put in the mesh repo and yeah, anything anywhere else.
So with that, we can leave it to everybody because you've learned how to do this at this point if you've been working through the course. I'm going to leave it to everybody to test these, make sure the tests meet your expectations, but then also try to make these tests fail and see if you can understand why they're failing. And if you have questions about any of that, bring it to a future live coding or meet up in the Gimbalabs Discord. But let's do a very quick overview of the rest of these guys now, right? The second file right here is just the tests in a separate file to the validator right here, showing you that just we can set up these value equivalencies and I'll let you kind of play with that. Okay, but let's look at another validator for just a minute. This one is similar to the last one, but we are paying attention to the datum this time. The datum is defined like this. It defines some minimum amount of Lovelace and a minimum amount of tokens. And as you're going to see down here, right, if there is datum, then what are we going to do with it? Well, we're going to check that the own address value is GEQ, greater than or equal to the amount specified in the datum, right? So the Lovelace has to be greater than or equal to what's specified in the datum, and some token amount, same thing. What token? Ah, look, that's a parameter to this validator. This validator at compile time asks you to define the asset that we are checking against with this quantity right here. And that's exactly what you see. Is there enough of that token? Which token? Ah, the one with the parameters. How much of it? Well, we're checking to see that the amount coming in is greater than or sorry, the amount that's being sent back out is greater than or equal to the amount specified right here, datum.minimum script token. This is common too, right, Hinson? Popular pattern. I want to be able to check the amounts of tokens moving this way or that.
Yep, I think so.
I'm only good if I'm building a DEX. I think that's going to be pretty important. I only want this validator to succeed when the numbers line up appropriately with the amount specified in some datum.
Yep. One thing is different to most of the production desks is this is only checking against one input. But for a lot of desks, we have to accumulate multiple inputs and group it into one check, and then have to allow other inputs to bypass the check, so to save up execution units.
Mm-hmm.
Yeah, it's become really complex really quickly. But if you just think about one UTXO as one order and each time filling one UTXO, this is the pattern that we usually coding. Yeah,
Very nice.
it's pretty straightforward indeed.
Very good. I like that idea of right, saving execution units by safely ignoring certain inputs. Yeah.
Yep, there are a couple of techniques, but we are not also not running into that today. If you're curious, I could talk about it after
I
that.
think we're going to go deeper into all these in weeks to come too. There's some concepts here that are going to be great to refer back to. Right. And this one, just to give full coverage, we'll wrap up in just a second, right? This one actually does have datum and redeemer. The datum is optional, but we're still going to validate against it. And then what are we doing? We're going to return true if some input datum has a secret message that matches what? Ah, the message in the redeemer. And we've looked at a similar example to this already, but this one is actually looking at the incoming datum. So basically here, the name of the game is for the person building the transaction to know the secret word that's locked up in the datum and then to provide it in the redeemer. And if they successfully provide it, they can unlock the UTXO. If not, they can't. Just keep in mind, and it says it in the course, that there really are no secrets in datum. Even if you hash the datum, that hash, yes, it's a one-way operation, but if there's enough value there, a powerful computer can just cycle through all of your possible passwords until it finds the one that matches a hash, right? Is somebody going to do that if there's 2 or 3 ADA to unlock? Probably not. But if there was a million ADA locked in a smart contract and it was protected by a single secret, quote unquote, secret word, do you think somebody would be willing to turn on their computer and just start brute forcing the calculation of a hash until they find the one? You can assume the answer is yes. Andrew Westerberg did a really good video, like showing like benchmarks for how long it would take to figure out what your datum was back in the day. That video is probably still pretty interesting to watch. So yeah, here we're just showing you how this works, but please do not ever use this validator in production. It's not secure. All right. And then finally, we can validate on outputs. So this one ties it all together, but I think this is where we should start next week. All right. We'll do a deep dive into 202.4. We'll look at this. This has two different. Notice closed state. That looks a little bit like that admin endpoint at the end of the Asteria validator we were looking at a little while ago. Okay. But I think this is a good place for us to cut today. Anybody have last questions before we break? Very good. Well, we'll do a deep dive into 202.4 next week, and then that's going to complete our initial run through the course. And that's really where the fun starts. So it'll be fun to finish delivering this initial content. We're going to keep these sessions going long after the content is delivered because we're going to be inviting people to work through this course. Andamio is going to be live next week, and people will be able to start playing around with earning credentials as Aiken developers. And at that point, I think symbolically, we're going to open up just a couple of little contribution opportunities at Gimbalabs just to start playing with this thing and seeing how it all works. So if there's time next week, I'll look forward to taking everybody through that as well. Well, that's all for today. Thanks for hanging out, guys. Small crew today, but we'll advertise these sessions a little bit more now that we're getting through the initial phase. Appreciate you all for hanging out and talk to you soon.
Yeah,
Cheers.
guys.
Have a good one.
Yeah, awesome.